Hello, everyone. This is Professor DePaulo. Welcome back to Site 220 Behavioral Statistics Lab. And today we're going to be talking about independent groups t-test compared to paired samples t-test. So with independent samples t-test, we have different individuals in each condition of the study. So for instance, if I'm looking at a weight loss study and the treatment group gets exercise and the control group gets chores, and I want to see, does exercise, lead to more weight loss or increase weight loss more than chores? I carry it out this way. I have a exercise group, which you call the treatment. Everybody in the exercise group is different, and they only participate in this one condition. They're all in treatment. The people doing the chores in the control group, these are all different people from the people doing the exercise group. So you have to have different individuals in each condition. And there's two conditions for an independent groups t-test. Now, if we're going to enter this into SPSS, we have to put all of this data into one column, which takes up 30 rows. So this is what it looks like. Weight loss. And all I did was I combined both columns. I did treatment first, and when the treatment was done, I put the control in. And that's 30 rows of data. So this is what we have to do. Every time we have independent groups, we have to have a column with all the data in it. And the dependent variable is weight loss. Now, the second column is going to be the treatment column. This is going to tell you whether they got the treatment, which is the exercise group, or they got the control, which is the chores group. So I'm calling this treatment. If they got the exercise group, I'm going to call 1. They all get labeled 1. This is what's called a dummy variable code. And then the control, I'm going to label as 0. Now, it doesn't matter. You can use 2. I think in the walkthrough, I might have used 2 instead of 1 and 0. I'm just going to call it 0 because I always like to call the control group 0. It doesn't really matter how you label it. The 1 only tells you that you're in the treatment group. The 0 only tells you that you're in the control group. It doesn't tell you anything else other than this, right? And we don't really need decimals here. Right? So this is a nominal variable, which shouldn't make much of a difference here, but I'm just going to call it nominal. If it asks me, it actually doesn't even ask me what to call it. It says measure unknown. I'm going to call it nominal. Okay. So this is a categorical variable. It's a dummy variable. All it is a label. So 1 means they got the exercise. 0 means they got the chores. Now, if I want to put this into the data set and go to variable view, go under where it says values, click the 3 dots there, right? And we can say that 1 is the exercise, right? This is in case I forget. And 0 is the chores group. Like that. And now I've labeled it. Go back to data view. And we're going to now test this hypothesis. Is there a difference in weight loss between treatment, between exercise and chores? And obviously, the null hypothesis is that there's no difference in weight loss between exercise and chores. The alternative is that, in this case, weight loss will lead to greater, exercise will lead to greater weight loss than chores. At least that's what I pretty sure I set up for this. All right, I'm taking a look at the other desktop. Okay, so we're going to do analyze, compare means, independent samples t-test for this. Weight loss is the test variable, that's the dependent variable. The treatment is called the grouping variable. And define groups, we have 0 and 1. You got to put the correct numbers down for the treatment column. So we use 0 and we use 1. And then we're just going to hit OK. There's a homogeneity variance test. We can skip that. Is there a difference? Well, look at exercise lost 16 pounds and the chore group only lost about 4 pounds. So that's a huge difference. Is that statistically significant? We're going to assume equal variance here because the larger variance, which is about 25, is not more than 4 times the smallest, which is approximately 9. So we're going to say equal variances. You can assume under a testing condition that we're going to be doing equal variances. There's my t-value, there's my degrees of freedom, and if I'm looking for a one-tailed test, it's less than 0.001. It's a huge difference. That's why it's very, very significant, highly significant. So how do we write this? There's always never enough room on the screen. So it's going to be t again. This is going to be degrees of freedom is n minus 2, so it's going to be 28 equals negative 8.372. And what's the p-value? P is less, comma, p is less than 0.001. And obviously we reject the null, right? We reject the null and we conclude that people doing exercise lose more weight than people doing chores. Nothing mind-blowing there, right? Unless those chores are really demanding. But I mean, regular household chores, you're not burning too many calories. If you're doing some crazy exercise, crazy aerobic exercise or weightlifting, you're burning a lot more calories and you lose weight more. But this just confirms it based on the sample. So you want to look for equal variances assumed when you do this. Look for the equal variance assumed, get the degrees of freedom, the t, the degrees of freedom, and then the p-value, and then determine whether you reject the null or you fail to reject the null. And that's independent groups. So let's look at another problem. So this was the huge difference here. Let's scroll down here and let's look at another example here. We are going to look at the grades.sav file to test the hypothesis that males and females perform differently in a statistics course. So gender is the independent variable and percent will be the dependent variable. So let's go into grades.save, which I already have open. Gender is independent, percent is dependent. So here's my grades.save file. Analyze, compare means, independent sample t-test. Gender is the independent for the grouping variable. Now you have to label this correctly, so we need to know what gender is labeled. So let's go scroll to gender. Is it 1 and 2? Is it male, female? I'm not sure what it is. It's 1 and 2. It's 1 and 2. It's not 0 and 1, it's 1 and 2. So we have to put 1 and 2 in there for the analysis, right? So analyze, compare means independent samples t-tests. We want gender as the grouping. We want percent as the dependent. And we're going to define gender as 1 and 2 because that's what we call it here. So it's already in here. Continue. Options, you can leave that alone. You don't need Bootstrap for this. Hit OK. What do we got? So it looks like females scored a little bit better, but it's very small compared to males, 81 to 78. Is that statistically different? And we look at this top row, equal variance is assumed, and we show that there is no difference, 0.103. And we wanted to test the hypothesis that gender perform different. So that's two-tailed, perform differently. Perform differently is two-tailed, so it's 0.206, still not significant, right? How would you write it? So we're going to do T again. Degrees of freedom is 103 here, equals 1.274. P equals 0.206. And that would be fail to reject the null. And so we cannot conclude that males and females differ with regard to statistics, final grades, or performance of a statistics class, or percentage in terms of an exam. I'm not quite exactly sure what this is. This might be one exam, might be the whole course. But there's no difference between males and females here. T103 equals 1.274, P equals 0.206. That's not less than 0.05. So we fail to reject the null. And that's how you do independent groups. Now, the most important thing about doing independent groups is that you are using one column, right? So let's go back and show you that again. It's the wrong file. We are putting all the data into one column for the dependent variable here. And then the treatment variable is a dummy variable. So you're always going to have a dummy variable when you have independent groups. When you have correlated groups or you have paired samples, you will not have the dummy variable. You only have the dummy variable for independent groups. So that's the most important part of this. So hopefully that helps. And we'll be moving on to paired samples next. And it's pretty easy to do these tests. You just have to format them correctly in SPSS. So bye for now. See you next time for correlated groups.